Hello everyone, welcome back to Physics HQ. This is Professor Sandeep, your tutor for the class 12 series. Continuing with the lecture series of solving MCQs and sums for class 12 physics, today we will be covering textbook unsolved sums of chapter 13 AC circuits. We have already covered MCQs of this chapter, and if you have not seen it, please check it out by clicking on the top right icon. So let us continue with our first sum. If the effective current in the 50 cycle AC circuit is 5 ampere, what is the peak value of current and what is the current 1 by 600 seconds after it was 0? The current over here is sinusoidal in nature. So if this is current with respect to time, we got this peak value over here, which will be nothing but I naught. What we are given in the question is effective current is 5 ampere. अब ये आप प्लीज याद रखना कि इफेक्टिव करंट मतलब आरएमएस करंट का बात हो रहा है. सो वी आर गिवन आई आरएमएस का वैल्यू ओवर हियर विच इज 5 एम्पियर. फ्रीक्वेंसी भी लोग ने दिया हुआ है 50 हर्ट्ज एंड देन दे आर आस्किंग द पीक वैल्यू ऑफ करंट ओवर हियर. Remember this formula, peak value of current is given as root 2 times RMS value of current. Now root 2 is 1.414. Try to remember this क्योंकि ये वाले chapter में कई बार आता है. And IRMS is given as 5. So if we multiply this, we will get peak value of current as 7.07 ampere. Now let us talk about the second part of the question. They are asking what is the current 1 by 600 seconds after it was 0. So at this point it was 0. So after moving for a time of 1 by 600 seconds, what is the current ka value that we have to find? So in this case what we'll do is we will use the instantaneous equation of current, which is given by I equal to I naught sine of omega t. We can write omega ki jagah pe 2 pi f into t. Let us put all the values. I0 we got 7.07 into sine of 2 pi we will keep as it is for now. Frequency is given as 50 and time is 1 by 600, right? So ये 50 2 जा 100 हो जाएगा यहाँ पे और ये 2 0 नीचे से cancel हो जाएगा. So we can cancel these things out and what we are left with is 7.07 into sine of pi by 6. Pi by 6 मतलब कितना हो गया 30 and how much is sine 30? Sine 30 is 1 by 2. So हमें क्या मिला यहाँ पे? When we divide this, we will get 3.535 ampere. So this is the value of current at time t equal to 1 by 600 seconds. Hope you all understood this. Let us check out the next MCQ. A light bulb is rated 100 watt for 220 volt AC supply of 50 Hz. Calculate the resistance of the bulb and RMS current through the bulb. सबसे पहला अपने पास यहाँ पे पावर दिया हुआ है which is 100 watt. Next we have is voltage of AC supply which is 220 volt. Now never be confused, जब भी लोग AC supply के बारे में बात करेंगे तो ये जो वैल्यू रहता है ये RMS वैल्यू रहता है, ठीक है? पीक वैल्यू नहीं रहता. ये कौन सा वैल्यू रहता है? RMS वैल्यू. Remember this. Frequency which is given over here is 50 Hz. Now let us find out the resistance of the bulb by using power at voltage. Formula that we'll be using over here is power is equal to E square RMS divided by R. If we interchange P and R, what we will have? R is equal to E square RMS divided by P. What is ERMS over here? 220. Let us take square of it divided by power is 100. So 22 ka square will be 484. 10 will become 2 over here. And denominator में we got 100. So these two zeros will cancel out and directly हमें यहाँ पे resistance मिल गया बल्ब का. कितना है? 484 ohm. Next part, they want the RMS current through the bulb. We know that power is nothing but ERMS into IRMS. So IRMS can be written as power divided by ERMS. Power is 100 over here. ERMS is 220. So we are left with 10 upon 22, which we can write it as 5 by 11. When we divide this, you will get 0.4545 ampere. Hope you all understood this. You can also calculate resistance by using the formula of ERMS upon IRMS over here. You will get the same answer. So this is another way of calculating resistance over here. Hope you all understood this. Let us check out the next MCQ. A 15 microfarad capacitor is connected to 220 volt 50 Hz source. Find the capacitive reactance and current, both peak and RMS, in the circuit. So capacitance is given as 15 microfarad and micro मतलब होता है 10 raised to -6. वोल्टेज जो हमें यहाँ पे दिया हुआ है 220 वोल्ट, जैसे हमने लास्ट सम में देखा, इट इज नथिंग बट ERMS and frequency is 50 Hz. First thing that we have to find out is capacitive reactance. Capacitive reactance is XC. This is given by the formula 1 upon 2 pi FC. Let us put the values. 1 upon 2 into pi is 3.142. Frequency is 50 and capacitance is 15 into 10 raised to -6. So once again ये 50 और 200 हो जाएगा and we will be left with 1 upon 3.142 into 15 into 10 raised to -4. -4 आप ऊपर लेके जाएंगे तो +4 हो जाएगा, and then you can multiply this and take the reciprocal by using the logbook. Finally you will get XC का value as 212 ohm. We are also supposed to find IRMS and I peak. So current is given by voltage upon resistance, but यहाँ पे resistance नहीं है, reactance है, capacitive reactance, तो हम लोग वो लिख देंगे यहाँ पे. ERMS is 220 and XC is 212. When you divide this, you will get 1.04 ampere. This is IRMS. Peak value will be √2 IRMS. ये हमने first sum में भी देखा था. Try to remember this formula. √2 is once again 1.414 and IRMS is 1.04. This will give us the value as 1.47 ampere. So हमें peak value भी मिल गया, RMS value भी मिल गया. Let us check the second part of the question. They are saying that frequency is doubled. What will happen to capacitive reactance and current? If frequency is doubled, then what will happen? Capacitive reactance का formula देख लेते हैं. The formula is 1 upon 2 pi FC. So over here what we see is XC is inversely proportional to frequency. तो अगर मैं frequency double कर दूंगा तो यहाँ पे नया XC क्या हो जाएगा, half हो जाएगा. Let me show it to you. So let us say if I change the frequency from F to 2F, I'll have this new XC denoted by XC prime. What I can do is I can take this 2 aside और ये 2 pi FC वापस से लिख देता हूँ. Now please tell me ये 1 upon 2 pi FC is nothing but अपना old वाला XC. So this can be written as XC upon 2. 2 यहाँ पे already बचा हुआ था. So what we see from here, the new XC or new capacitive reactance is old capacitive reactance by 2. Let us talk about current. Current का formula is ERMS by XC. Let us put the formula for XC over here. So XC is 1 upon 2 pi FC. So ये numerator में चला जाएगा 2 pi FC. And from here what we can say is I is directly proportional to frequency. तो अगर आप frequency double कर दोगे तो current भी क्या हो जाएगा, double हो जाएगा. So current will double if frequency is doubled. Hope you all understood this. Let us check out the next MCQ. An AC circuit consists of only an inductor of inductance 2 Henry. If the current is represented by a sine wave of amplitude 0.25 ampere and a frequency of 60 Hz, calculate effective potential difference across the inductor. Once again, effective मतलब RMS value. Don't forget this. Let us write down whatever is given. We have inductance of 2 Henry. We have amplitude of current, मतलब peak value हो गया. So peak value is 0.25 ampere. Frequency is given as 60 Hz and we are supposed to find out what is ERMS, the potential across the inductor. So ERMS का formula क्या हो जाएगा, जैसे V is equal to IR होता है, यहाँ पे ERMS will be equal to IRMS into, अब यहाँ पे resistance नहीं है, इंडक्टर है, तो इंडक्टर का XL. So ना हमारे पास IRMS है ना हमारे पास XL है. Let us find them out. So XL is equal to 2 pi FL. Let us put the value 2 into 3.142 into frequency is 60. Inductor का value is 2. So यहाँ पे what we can do is we can multiply it by 12 first and then 2 या फिर 6 and 4 separately आप multiply कर लो so that you can get the answer easily without using the logbook. The final answer that you will get is 754.08 ohm. So this is XL का value. IRMS is maximum value by root 2. Now always remember 1 by root 2 is nothing but 0.707. 1 by root 2 is 0.707 and I0 is given as 0.25. So remember these two things. Root 2 is 1.414 and 1 by root 2 is 0.707. These things will help us to solve the sums very quickly. Over here, either you can multiply this by 25 or 0.25 can be written as 1 by 4. 0.25 is nothing but 1 by 4. So let us divide this. We will get the answer as 0.1768 ampere. So we got IRMS also, we got XL also. Let us put it over here. So 0.1768 into XL we got as 754.08. Now please use the logbook to solve this problem. And the final answer that we'll get is 133.4 volt. If you have any query in how to use the logbook, please click on the top right icon and check out the video on how to use logbook for solving sums. Hope you all understood this. Let us check out the next question. Alternating EMF of E is equal to 220 sine of 100 pi t is applied to a circuit containing an inductance of 1 by pi Henry. Write an equation for instantaneous current through the circuit. What will be the reading of the AC galvanometer connected in the circuit? So what we are given is E is equal to 220 sine of 100 pi t. If we compare this with the standard equation E0 sine of 2 pi ft, what we get is the peak value is 220 volt, 2 pi f over here is 100 pi, and if we cancel this pi and pi, we will get f is equal to 50 hertz. We are also given inductor ka value which is 1 by pi Henry. So we can find out XL which is equal to omega L, or you can write it in the form of 2 pi L. So we can write this in the form of omega L also. When you compare this with sine of omega t, you will get omega 100 pi, L ka value is 1 upon pi. So when these two cancel out and we get XL equal to 100 ohm. Now we are supposed to write down the instantaneous equation for current, and in this circuit inductor is connected. So the equation will be I equal to I0 sine of omega t minus pi by 2. Why is this minus pi by 2 over here? Because when you have an inductor connected in the circuit, pure inductor, the current will lag by 90 degree. Remember this. For a capacitor, current leads by 90 degree. For an inductor, it lags by 90 degree. So I0 will be basically E0 by XL. Current is like V by R. तो यहाँ पे V की जगह पे we got EMF E0. R तो है नहीं यहाँ पे. We don't have resistance. We have inductance. So हमने XL ले लिया हुआ यहाँ पे. Then you got sine of omega की जगह पे we can write 100 pi t minus pi by 2. Let us calculate what will be E0 by XL and put it over here. E0 is 220 and XL is 100. Sine of 100 pi t minus pi by 2. This is equal to 2.2 sine of 100 pi t minus pi by 2. So this is the instantaneous equation of current for this circuit. Lastly, what will be the reading of the AC galvanometer connected in the circuit? So when we connect a galvanometer, the galvanometer gives the reading of RMS value. So basically they are asking what will be the RMS value of the current. We know that RMS value is nothing but maximum value divided by root 2. This is equal to 2.2 divided by root 2. And जैसे मैंने आपको लास्ट सम में भी बताया था, 1 upon root 2 can be written as 0.707. This makes sum थोड़ा सा easy to multiply, or once again you can use log to multiply this. The final answer that we get is 1.554 ampere. Hope you all understood this sum. Let us check out the next sum. A 25 microfarad capacitor, 0.1 Henry inductor and a 25 ohm resistor are connected in series with an AC source whose EMF is given by E equal to 310 sine of 314t. What is the frequency, reactance, impedance, current and phase angle of the circuit? So let us write down quickly whatever things are given. Capacitance is 25 microfarad. Micro is once again 10 raised to minus 6. Inductor is 0.1 Henry. Resistance is 25 ohm. EMF is 310 sine of 314t. Now when we compare this with E equal to E0 sine of omega t, we get maximum value of EMF or peak value as 310 volts and omega ka value we got 314. Now from this omega we can find out frequency. Omega can be written as 2 pi f. This is equal to 314. So frequency will be 314 divided by 2 into pi. So 314 divided by 2 into pi ke jagah pe we can write down 3.14. This will cancel out over here and we will have 100 and 100 by 2 will give us 50. So the frequency that we got is 50 Hertz. Next we want to find out the reactance. Reactance mein we need to find both the reactance XL and XC. So XL is given by the formula omega L, or you can also write it as 2 pi FL. So this is omega which is 314 and L ka value is 0.1. So we got the answer 31.4 ohm. Let us talk about XC. This is 1 upon omega C. So we got 314 into capacitance ka value is 25 into 10 raised to minus 6. Now we can try to simplify this. 10 raised to minus 6 ऊपर जाएगा तो हो जाएगा 10 raised to plus 6. 314 into 25. We can take two zeros like this and we can write it as 10 raised to 4 so that the 25 cancel हो जाए. And then we got 4 upon 314 into 10 raised to 4, or you could have directly used log to solve this. Final answer that we will get is 127.4 ohm. So this is the value of XC. So we got both the reactance, capacitive as well as inductive reactance. Next we are supposed to find out the value of impedance, which is Z. Z is given by the formula under root R square plus XL minus XC the whole square. So this is equal to under root R ka value we have 25, XL we got 31.4 minus XC we got 127.4 the whole square. So this is equal to root of 25 ka square will be 625. 31.4 minus 127.4 will give us 96. Minus 96 square लेंगे तो वो चला जाएगा anyways. This will be 625 plus we can use logbook again to find the square of 96. It comes out to be 9216. When we add it up we get 9841, and once again we can use the square root wala table to find the square root of this, or you can use log to solve this. Final value of impedance comes out to be 99.2 ohm. Then we are supposed to find out the current over here. Current will be given by IRMS is ERMS by Z, but we don't have ERMS, so we can write it as E0 by root 2 into Z. Let us put the values. E0 is 310 root 2 and we got Z ka value over here. Z is 99.2. Again यहाँ पे we cannot avoid log over here. Therefore I continuously tell you all to please understand how to use logbook quickly. You can always click on the top right icon to select the video on how to solve sums using log. उसके अंदर मैंने आपको log, antilog, sine, cosine, square root, reciprocal सारा example के साथ में समझाया हुआ. Please have a look at it, or else it will be very difficult to solve the sums. So when we solve this by using log, the final answer that we get is 2.21 ampere. Lastly, we are also supposed to find out the phase angle. Phase angle phi is given by tan inverse XC minus XL upon R. This is equal to tan inverse. We have already taken the difference, which comes out to be 96 divided by R is 25. So we need to find out what is tan inverse of, when we divide this we will get as 3.84, and we can check this out from the natural tan ka table. Please select natural tan ka table from the logbook. You will get the answer as 75.4 degree, and you can convert this into radian as well. 75.4 into, when you multiply it by pi by 180 you will get answer in radians. Pi ki jagah pe I am writing 3.142 divided by 180. This will give me 1.316 radians. So this is the phase angle. It was a lengthy sum, but as you can see we need to use log every now and then, and it is very difficult or almost impossible to solve these kind of sums without using logbook. So hope you all understood this. Thank you for your time. If you're finding this lecture series useful, then show us your appreciation by clicking on the like button, and don't forget to share it with your friends and classmates. And as you know, based on your feedback and suggestions, we'll be covering key concepts under our 5 minutes lecture series of class 12. So please feel free to let us know the topic you want us to cover. See you all in the next class. This is Professor Sandeep from Physics HQ signing off.